So I'm going to talk to you guys about the P versus NP problem. Have any of you heard of this before? It's a mathematical problem. Okay, so I'm just going to introduce it like this. So, what is 3 times 7?
21.
Yes. What are the factors of 21?
73.
Oh yeah, I said 7. Yeah, 73, okay. So, what is 583 times 8,024?
Great question. I don't know. Not off the top of my head.
But if I give you this whiteboard and a marker, you could do it
Yes.
pretty fast, right? And if I had a computer do that problem, it could also do it pretty fast. But what if I multiplied 5,098 times 246, or whatever I said, together, and I had that new 6 or 7 digit number, and I asked you to find the factors of that number? How long would that take you? A very, very, very long time. Because how would you find those factors? You would have to check almost every single number, probably not the evens. You have to check every single number to see if your number is divisible by that to find the factors. So it would take you a long time, and it would take a computer a long time too, because you have to go through every possible solution. So this is an example of what I said in talking about, the P versus NP problem. So multiplication is what's called, or is what's considered a P-type problem, where the amount of time it takes to solve your problem, to multiply 3 times 7, is directly proportional to the size of your problem. So 3 times 7, pretty quick. 5,096 times 24, longer, but not too long. It's still pretty quick. But finding the factors of 21 takes, a second. Finding the factors of a 7-digit number takes forever. And it takes a computer forever too. So the P versus NP problem asks, for every problem that is in P, can you actually solve, or for every problem that is in NP, can you actually solve it as a P problem? So is there actually a way for me to take any factorization problem and solve it as instantly as it would take me to multiply those two factors together? So, okay, I'll give you another example of this. Say I am throwing a party, okay? And so I want to invite people who are my friends, right? So say these are my friends, and I'm going to represent these as nodes on this board. And so some of my friends are friends with each other, right? So I'm going to represent that as friends as dots who have lines connecting them. So this is my friend AJ, and this is my friend Andrew. They have a line, so that means they know each other. So I'm going to draw some lines. So these are my friends, and that's how they know each other. Now I want to throw a party, but obviously I want to throw the most fun party possible. So I want to throw the biggest party I can. What's the biggest party I can throw? How many people? Anybody see?
Can you use like a permutation or combination formula? What is it?
No, you would have to. So how do you mean to use the combinations?
You know, like permutation combination formula, like I don't know, it's like the factorial over n factorial times like n minus n factorial.
But that would tell you how many possibilities of parties I can throw. But I want to know what's the biggest party I can actually throw. So I only want to throw a party if everyone at the party knows each other. So you see how these people have lines connecting them? I can throw a party with just these 3 people. But I can't throw a party with this person and this person. Does that make sense? So, as you can see, the biggest party I can throw would be 1, 2, 3, 4 people who all know each other. Or these 4 people. That was pretty quick. But what if I had 1 million friends? Or 1 billion friends? It would take me forever to find the biggest party I could throw. And it would take a computer probably years. Okay? So, as you can see, problems that are in NP take a very long time to solve. And they're actually the basis of a lot of very important things in modern technology. Probably the most important would be security, in that it makes up encryption, right? So one of the most common ways to encrypt something on the internet is to have it to where you can only access the thing that is encrypted if you have the factors of a number, and this number might be 40 digits long. So about 20 years ago, they started, technology companies started posing prizes. So they would say, we will give $10,000 to the first people who can give us the factors of this 8-digit number. And now it's up to 15-digit number. Because they want to assess how good is technology at solving these problems quickly. So all of that would go out the window if somebody actually figured out a way to say P is equal to NP, therefore I can find the factors of that number like that, no matter how long it is. So, yes, so P versus NP is basically, think of a needle in a haystack. If I have a haystack, what is the only way to find a needle in this haystack? You ready? Yeah, you got to dive into the haystack, and you got to look at every individual grain of hay and see whether it's a needle. But P versus NP asks, is there a magnet that I can hold up to this haystack and pull the solution, the needle, straight out of it? So, yeah, that's P versus NP. And it's also, it's one of the 7 Millennium Problems that was posed in 2000. And each of them have $1 million prize if you manage to solve them. So most mathematicians actually think that P is not equal to NP because it would basically make almost every problem able to be solved instantly. And that seems unlikely. So, but if you can prove it one way or another, you can win $1 million. So.